Hi, today I'll be going over 5.4, which is factor and solve polynomial equations. So there are some special cases I wanted to go over before we do some problems. So there is the sum of two cubes. So if we have a cubed plus b cubed, that will factor into a plus b times a squared minus ab plus b squared. And the difference of two cubes is a squared, a cubed minus b cubed, and that will equal a minus b times a squared plus ab plus b squared. So if you look at the equations, they're very similar besides the plus and minus signs. So a way to remember is SOAP. So the first one is the same, and then opposite, and always positive. So if we look at the first one, a cubed plus b cubed, the first will be the same. So since the original sign was a plus, the equation will also have a plus. Then it'll be the opposite sign, and the last one is always positive. And we can do the same thing for the negative. So if we started with a minus here, it would be the same sign first, so the minus, and then it will be the opposite sign, so that's why that's a plus, and the last one is always positive. Okay, so let's do a couple examples. First, we want to factor completely. We have 30x cubed minus 54x squared. So looking at the numbers 30 and 54, the greatest common factor is 6. And in x cubed and x squared, the greatest common factor is x squared. So if we factor out a 6x squared, we're left with 5x minus 9. And we can't factor anymore, so this would be our final answer. Okay, next we have x to the fourth plus 5x squared minus 6. So we can solve this very similarly to quadratic equations. So we'll draw our x. On the top would be negative 6, and on the bottom is 5. So that's negative 1 and 6. But on the top this time, we're going to put in x squared, because x squared times x squared is x to the fourth. And if it helps, it should always match this middle one. So this would be x squared minus 1 times x squared plus 6. But x squared minus 1 is a difference of two squares, so we can factor that further into x plus 1 times x minus 1, and then x squared plus 6. So this would be factoring it all the way, or factoring it completely. Okay, next we have sum or difference of cubes. So for this first one, we have 27x cubed minus 1000. So that means a is 3x, because the cube root of 27 is 3 and the cube root of x cubed is x, and b is 10 because the cube root of 1000 is 10. So we can plug this into our difference of two cubes equations. So this would be a minus b times a squared plus 2ab plus b squared. So that would be 3x minus 10 times 3x squared, which is 9x squared. Oh, oops, sorry, there's no 2 here. So plus ab, so that'll be plus 3x times 10, which is 30x, and b squared is 100. And this part here will never be factorable, so you can always just leave it after you plug it into the difference or sum of cubes. Okay, next one we have negative 125x cubed minus 216. So first I'm going to take out the GCF, which is the negative sign. So that's 125x cubed plus 216. And then from here, I'm going to find a and b. So a is going to be 5x, and b is, sorry, I didn't calculate this earlier. I think it's 6 though, but let me check. Okay, yes, it's 6. So that means b will equal 6. So we're going to plug this into the sum of two cubes. So that would be a plus b times a squared minus ab plus b squared. So we're going to keep the negative, and then we'll get 5x plus 6 times a squared is going to be 25x squared minus a times b is 30x, and b squared is 36. Okay, the next part is factor by grouping. So anytime you see 4 terms, that kind of gives you the hint that you're going to be factoring by grouping. So what we're going to do is group the first 2 terms together and the last 2 terms together. So in 3x squared minus, or 3x cubed minus x squared, the GCF is x squared. So I'm going to factor that out, and if I do, I'm left with 3x minus 1. And then in the second group, the GCF of 9x minus 3 is 3. So I'm going to take out a 3. So we have 3x minus 1 in both of them, so that's like the GCF of them, so 3x minus 1. If we factor that out of the first part, we're left with x squared, and if we factor that out of the second part, we're left with plus 3. Okay, next we have 2x cubed plus 10x squared minus 18x minus 90. So first I want to take out a GCF if there is. For this problem it would be 2. Okay, now that I see there are 4 terms, I'm going to group the first 2 terms together and the second 2 together. So in the first part I can take out an x squared and I'll be left with x plus 5. And in the second part, whatever I factor out, I want to be left with x plus 5. So since I want it to both be positive, I'm going to factor out a negative 9. So that this would be x plus 5. Because if it's not the same, then we can't factor out the x plus 5. So they have an x plus 5 in common, so we can factor that out. And if we take that out, we're left with x squared minus 9. And x squared minus 9 is a difference of 2 squares. So I'll factor into x plus 3 and x minus 3. Okay, and the last section is solving equations. So for this first one, we have a common or greatest common factor of 4. So I'm going to take out a 4. And since we're solving, we can divide everything by 4 so that we don't have to deal with it anymore. So x to the 4th plus 10x squared minus 11 equals 0. So anytime you have 3 terms like this and this first one, or the exponent is like this one times 2. I hope that makes sense. So since 4 is double of 2, we can use the x method to factor. So that means on the top we have negative 11 and on the bottom we have 10. So that would be 11 and negative 1. And on the top we'll have x squared, because this is x squared. And x squared times x squared is x to the 4th. So this will factor into x squared plus 11 times x squared minus 1 equals 0. And x squared minus 1 is a difference of 2 squares. So we can rewrite that as x plus 1 times x minus 1 equals 0. So now we're going to set each one equal to 0. So x squared plus 11 equals 0, x plus 1 equals 0, and x minus 1 equals 0. So for this left one, we will subtract 11. So x squared equals negative 11, and then square root both sides. So I get x equals plus minus, don't forget the plus minus anytime you take a square root, of I, since we can break up negative 11 to negative 1 times 11, rad 11. Then for the next one, we're going to subtract 1, so x equals negative 1. And for the last one, we're going to add 1, so x equals positive 1. So the answer would be, all 4 of these. So x equals plus minus I rad 11, negative 1, and 1. Okay, this last one, we have 5x cubed plus 15x squared plus 12x equals negative 36. So first we want to move the 36 over. So we get 5x cubed plus 15x squared plus 12x plus 36 equals 0. And since we have 4 terms, we're going to factor by grouping. So I'm going to group the first 2 together and the last 2 together. So from the first 2, the GCF is 5x squared. So I'll be left with x plus 3. And in the second 2, the GCF is 12. So from these 2, the GCF would be x plus 3. So we can factor that out of each one. And we're left with 5x squared plus 12 equals 0. So then from here, we're going to set each one equal to 0. So x plus 3 equals 0, and 5x plus 12 equals 0. So this one we're going to subtract 3, and we get x equals negative 3. So that's going to be one of our answers. And then for the other one, we have to subtract 12 first. So we get 5x squared equals negative 12. And then we're going to divide by 5. So we get x squared equals negative 12 over 5. Then we're going to square root both sides. So we get x squared equals, okay, so 12 will break up into 4 and 3, and 4 breaks up into 2 and 2. So there's a pair of 2's that can come out and a 3 that will stay inside the square root, and the negative will become an I. So this will equal plus minus 2i rad 3, so that's what the negative 12 is, over rad 5. And in the last chapter, we learned that we can't have radicals in the denominator, so we're going to multiply by the conjugate, which is going to be rad 5 over rad 5. So then x will equal plus minus 2i rad 15 over 5. So these would be the other 2 answers. And that's it. Okay, thank you so much for watching.